Okay, today is the November the 10th. We passed our 1 month mark a couple of days ago that we started on this. But got an issue here because the motor is backwards. It puts the rotation backwards on our output drive. So we solved the back end of that by flipping the differential over. So we got that on the back side taken care of. Now on the front side, we could do the same thing. We could pull that differential, cut all the mounts off, flip it over, and relocate it, weld all the mounts back in, and do the same thing. Problem is, we've already got a high input pinion, and I kind of like to keep that. Plus, that's a lot of work. Doable, yeah, but I think I've come up with a better way here because you still have to reverse rotation. So what I'm going to do is actually build a reversing gearbox that bolts right onto the back of the transfer case. And I'm going to try and explain where I'm headed with this, and it kind of evolves as I go. So I sit down, and these are certified engineering drawings, by the way, certified by somebody. A little bit of CAD design, that's cardboard aided design. But in any case, this is kind of our concept drawing of how we got to make this work. Okay, so we cut some of the parts here. This is a piece off a 231 transfer case, same as that one. We're kind of using it as a mock-up here. So we cut its plate, which we're going to bolt on. Show you what I'm doing here. We'll bolt it on like that, and that'll be our base frame. And one of the major things we had to come up with was how to accommodate for the oil pump. See, it fits in here, something like that. But the part of the output housing is actually cut so that it fits over these ears on the pump to hold it in place. And it's also got this guide ring right here that goes down inside the cage to keep it all lined up. So what we did, cut us a little ring that would fit right in there, and what we'll do is take that ring, I'm trying to keep this to where you can see what I'm doing. Take this ring and mount it right down in there, keep everything lined up. And what we'll do is weld this right onto that plate all the way around here. That'll give us a good oil seal so we're not leaking oil all over the place. But on the back side, after we get this located, we're going to have to notch it out for these. So what we'll do is just figure out where they have to be. We'll set it up in the mill and mill out those where they fit. So that should take care of our pump issue. Okay? Hopefully. And like I say, this is evolving as I go. We just rough cut this plate out, and you see I haven't cleaned it up very well. Just mock up so that we can tell what we're doing. So then I got, these will be kind of our body of our gearbox, like so, which will weld onto this plate. And because these holes here are so close, mounting holes, I can't even get them in. So I'm going to have to cut a relief in this to even get the heads of these socket head screws in. These are 10mm bolts, by the way. So one thing I can do is after I weld this on, I can clean it up good and actually clamp. You can see we got a little bit of gap here, and I can actually clamp this closed and then weld it right around here, so that that'll give us a little more room here. And I'll probably have to do that. When I cut this piece out, this tube actually expanded about 1/4 inch, so it's actually worse now than it was before I cut them. So I think that's what we'll do, is probably collapse that a little bit, weld it in place, and that'll give us a little more clearance for these bolts. And I got 3 of them on the outside, but one of them's going to be inside the case, which is okay, because to assemble this, I'm going to have to put basically this part on, and then put all the gears in, and then cover it with plate. So this is kind of this is our mock-up of how things are going to fit. This is an output shaft off a 231 transfer case, and that we cut up to make the doubler for Klondike. It's the same as that one sticking out over there. So what we'll end up doing is cutting this off right there where that snap ring fits. And of course this bearing will fit on here then. And the support bearing on this side is inside the transfer case. Okay, so now this one here will be our output shaft for our front differential drive. And we're going to use this yoke, but we're going to have to machine this down for this bearing to get it in our case. This distance right here is 3 inches inside this plate to the inside of the top one. Okay, so that's what we're trying to get it as small as we can. That's about as good as we can do. So anyway, we're going to have to machine this off down to here to put that bearing in. And we're also going to have to machine this side because this is too big, and it's also a little bit too long. So we're going to have to cut it off somewhere about right there, and then machine this down to fit the bearing. So I don't know if that kind of explains what we're doing here or where we're headed. It seems like everything I decide to do, I have to change it a little bit here and there. So anyway, this gear I'll show you how I had to do this one. This is on the output shaft. This is actually where the reluctor gear for the pickup for the speedometer fits. Well, I took that reluctor gear and machined it down so that it would fit inside this gear. And it's loose right there, but I need to weld this in here, and on the inside weld it right to this gear. Now this gear this was actually the tapered gear for the synchronizer. So I cut that off because it was way too long. But I didn't have to cut this part off, so I can weld that reluctor gear right into the inside of this, and that gets all their distances right. And it also centers the two gears right in the middle of our case. So, I'm going to set this over here like so, just to give you an idea how it's going to be now. On this side, I'm just going to weld this ring once I get my distances right. I'm going to weld this ring in place. And then that bearing will sit right down in that ring. Okay. Now we'll have a similar thing on our cover plate for this bearing on the inside of it. And of course this shaft will be cut off right there so it won't stick through the plate. Now this one I'm going to have a hole. Oops. That's going to be our output shaft. Okay. So when we get this lined up, this is going to stick out for our yoke. So what I did, I machined this piece, well, which will actually weld into the cover plate, and this side for the bearing, it'll actually fit this one. That side for the bearing to support the shaft, and then this side will hold the seal. It goes around the end of the yoke. So I think that part will work really well. Now, something I just barely considered about a half hour ago, because what I was going to do is cut a plate, weld it on the outside of here, flush with the top of this, and drill holes in it for the cover plate to bolt to. Well, I've just changed my mind. I think what I'm going to do is cut one to fit on the inside and weld it up, and it'll only be about a 1/2 inch wide, and have holes that will, so I can still drop the gears down inside. Now, a 1/2 inch will give me enough room that I can put however many bolts I need in there. I can put 8 or 16 or 50 if I want, doesn't matter, just something so that it holds everything solid and seals it up well. So anyway, that's kind of what we're headed for, and I'll do another update after I get some of this machine work done and some of these other parts fit, to kind of document where we're going. Something I wanted to explain here, these gears that I'm using are the chain drive gears out of a transfer case. These are out of a 231. Also got these, they're exactly the same gears They're 34 tooth, 20-degree pressure angle spur gear. So for them to work, I mean, they're like perfect for this application. So, and I was kind of surprised to find that out, because it's the first I've ever tried to do anything like this, so I'm learning as I go. So this is going to be, and these things are 1.125 wide. So they should be plenty heavy duty, and they're very, very hard. When I cut this off, I tried to do it with the bandsaw, and it would not cut it. I chucked it up in the lathe, and it would mark it, but it wouldn't cut it worth a darn. So I ended up cutting this off with the cutoff wheel, and then just dressing it up a little bit, just to true this up. So I've also got these gears. These are out of a Borg-Warner transfer case, and I thought that was interesting that they'd be exactly the same gear. They're 34 tooth, same as these. One of them is 1.125 wide, and the other one's only 1 inch wide. Now, why that is, I haven't a clue. I don't know. But I did think that was interesting. Also, these bearings are also the bearings. This is two 6207 bearings out of the transfer case. These are extra ones I had from the Klondike gearbox, plus the one that I pulled out of the output shaft on that. So these are going to work really well for this. They're open bearings, which you need to get them lubricated. Right now I got dirt and junk in them, so I'm going to have to make sure they're all cleaned up good before I put them together. But anyway, that's where my parts are coming from. So here we go. I wanted to show, we've got this mounted on the transfer case. Got our gears set in there. Let's see how we welded this piece on, then drilled it and tapped it. We drilled this. We tacked it right onto that plate so that all the holes line up. And there's about, I don't know, 16 or so. But just wanted to show how all this fit together. And you see we cut this off of here so that we didn't have to worry about it sticking through the plate here. And so now we'll put that all back together. I still got to do some shimming. That's a little bit loose on this end, so just got to make sure that our shimming's right for our gears. May have to do something to this one too. It's sticking out just a little bit more than I want, and I haven't put the retainer ring on here yet, and I haven't put the one on the back of this to hold it onto the shaft. So I haven't quite finished that up. That's minor stuff. We know that it's all fitting on there and should work good. So there we go. Got our gearbox in. We set it in there. It's pretty tight. I still got to take it back off and set the end play on the two shafts. So, but other than that, it's finished. Really like how it turned out, and you can see how much better our drive line's gonna line up with that setup for the front diff. So, yep, really happy how that turned out. So, yep, liking that a lot. So I've been on that for like more than 6 days. Probably got, I don't know, 40 or 50 hours into that thing. But it's done now. So I really like how it's set up. Now we can move on to, we got to pull this cross member here, transmission mount, and finish welding it. Then we can tighten up our tie rods or torsion bar and get that part done. We still got a lot of work to do. Still got to pull these off and weld them. The front, I'm just dropping everything here. The front engine mount's finished. That's a done deal, other than painting it. Yeah, these got to come off so we can weld them. And then we got to run all of our, put all our lines back in. Brake lines, power steering's got to come up from the pump up here on the engine back to the gearbox up there. Fuel lines, because the fuel tank's going to be up there, and that's got to come back to the engine. So still got a lot to do, but that's a biggie right there. Really glad to see that finished.